This question asks us to use the properties of logarithms to rewrite the following as a sum or difference of multiples of logarithms. So how are we going to do that? Well, we've got to remember our basic rules. So let's take a look at those. There's really only three of them to keep in mind primarily. Log base b of m times n. So the log of the product is simply log base b of m plus log base b of n. So again, logs turn multiplication into addition. They do not turn addition into multiplication. So that's important to remember. The next thing is if I have a quotient, log base b of m over n is log base b of m minus log base b of n. So again, log turns a quotient into a difference. And finally, if you have an exponent, right, log base b of m to some exponent p, the exponent comes down front. That's p log base b of m. So those are our three rules of logarithms. So what we have first here, we have log of the top over the bottom. That's the log of the top minus the log of the bottom. So we can rewrite this how? Using this second rule. Log 2 of the top, x to the fifth y cubed, minus log 2 of the bottom of z to the seventh. That's the first thing we recognize. Next, we recognize here I have log of a product. Log of mn is log m plus log n. So log 2 x to the fifth plus log 2 y to the third. Log 2 x to the fifth plus log 2 y to the third minus log 2 z to the seventh. And then the last thing we can do is our third rule here, which enables us to pull the exponents down. So the 5 can come down, the 3 can come down, the 7 can come down. So then we get 5 times log base 2 of x plus 3 times log base 2 of 7, excuse me, log base 2 of y, minus 7 times log base 2 of z. So I've written this as a sum and difference of multiples of logs, right? 5 times log base 2 of x plus 3 times log base 2 of y minus 7 times log base 2 of z. That is that thing written as a sum of multiples of logs using these three rules. Now, what's my next question? The next question I have is natural log. Remember, natural log is log base e. So what do I want to do there? I want to take a look at the following, if I can. Natural log of p squared over q root r trying to see how much of this I can actually use. You can keep those three rules in front of you. Oh, too far over. There we go. So there's my three rules that I have for the logs. And the question I want to do here is, again, natural log p squared over q root r natural log p squared over q root r. So we start with that. That is the log of a quotient. So log of something over something, log of the top minus log of the bottom equals log of the top, p squared, minus log of the bottom, q root r. So we get log p squared. We'll deal with the exponents at the end minus. Now log of q root r, the log of the product, log of mn is log m plus log n. So natural log q plus natural log root r. Well, let's distribute that minus sign. So then I get natural log p squared minus natural log q minus natural log root r. But what is root r? Root r can be thought of as r to the 1/2 power. So we get natural log p squared minus natural log q minus natural log r to the 1/2 power. At this point, we can pull the exponents down, right? The 2 comes down in front, the 1/2 comes down in front. So we get 2 times natural log p minus natural log q minus 1/2 natural log r. That will be our expanded version, rewriting as a sum or difference of multiples of logarithms.